So I have the pleasure of showing you around Yellowstone for a little bit, and just to show you this picture here, this is a picture of famous Grand Prismatic Spring. It's one of the largest hot springs on the planet, and you can see the wonderful colors from Grand Prismatic, and that represents the different temperature environments, hottest in the middle and cooling off as you get towards the edge, and that's from the different bacteria that grow in the different temperature environments in this hot spring. So Yellowstone is well known for its past explosive volcanic eruptions and lava flows, as well as its world-class hydrothermal system. I am Jamie Farrell, like was announced. I work at the University of Utah, and then also I have a role as the chief seismologist for the Yellowstone Volcano Observatory. My co-authors are Mike Poland, who works for the United States Geological Survey, and he's the scientist in charge for the Yellowstone Volcano Observatory. Madison Myers from Montana State University, and Bob Smith, who's also at the University of Utah. So where is Yellowstone? If you don't know, Yellowstone is located in the northwest corner of the state of Wyoming in the United States, shown here. And if you zoom in a little bit, this green outline here is the outline of Yellowstone National Park, the world's first national park. And you can see here, this is the outline of Wyoming here, this is the state of Idaho, and this is the state of Montana. So Yellowstone sits 96% in Wyoming, 3% in Montana, and 1% in Idaho. And one of the wonderful things about the Yellowstone region is it's one of the most intact ecosystems on Earth. You have Yellowstone National Park, which is protected. To the south, you have Grand Teton National Park, and then Yellowstone is completely surrounded by national forest. So a lot of the natural processes are allowed to go on, as well as large megafauna and the animals that live in the region. So even though we tend to focus on the younger volcanic eruptions in Yellowstone, the Yellowstone system indeed is much older than that. It's a hot spot, and you can see here it started around 17 million years ago down here in northwest Nevada, where Nevada, Oregon come together here. And each one of these yellow polygons are a conglomeration of eruptive centers, and the numbers are dates in millions of years ago. So you can see they get younger as they move up the Snake River Plain up towards current Yellowstone right here. And of course, this is due to the southwest motion of the North American plate at about 2 centimeters per year over the hotspot. Shown here in red are earthquakes of the region. Yellowstone sits in the middle of what's called the Intermountain Seismic Belt. You can see this pattern of earthquakes coming up from Utah up through Idaho, Wyoming, wrapping around Yellowstone into Montana and Idaho. And we call this the tectonic parabola, and this is the influence of the hotspot, a bow wave, if you will, as the hotspot moves its way through the North American tectonic plate. And one interesting thing about Yellowstone as well is that obviously you have the volcanic system, but it's overprinted on the basin and range tectonic province. So you have this kind of combination of active tectonic processes and this volcanic system, and how those two interact is a very interesting topic that a lot of people have looked at. So if you look closer at Yellowstone, this is a map again. This is the outline of Yellowstone National Park here. Shown here are the many faults in and around Yellowstone. These light or the small black lines are all the faults that have been mapped in and around Yellowstone. I've outlined the larger ones in red here, and these are all normal faults, basin and range style normal faults that are accommodating extension across Yellowstone. And you can see most of these faults come up and terminate at the caldera boundaries. I can show you, I'll tell you that real quick before I go on. These are the three most recent caldera boundaries here. So caldera 1, the largest, is this one that wraps around down here. This is caldera 1. This is 2.1 million years ago. Some people think that it actually extends up to the north, up here as well. Caldera 2 is the smaller of the three, 1.3 million years ago down here in Idaho. And then caldera 3, which we call the Yellowstone caldera, outlined here. This is the caldera that formed 630,000 years ago. And you can see these faults all come up and they all terminate here at these caldera boundaries. And the idea is that these were once continuous faults, basin range type faults across the caldera, and they've all been destroyed in the subsequent volcanic eruptions. I've outlined here the two resurgent domes within the caldera. This is the Mallard Lake resurgent dome, and this is the Sour Creek resurgent dome. Then you have the Elephant Back fault zone that connects the two resurgent domes. Now, when we talk about these volcanic eruptions in Yellowstone, these are really large eruptions. And here is a depiction of some of the deposit distributions of the ashfall from these eruptions. You can see the three here. So Huckleberry Ridge Tuff, right here is the 2.1 million year old eruption. Lava Creek ash bed is the 630,000 year old eruption. And then the Mesa Falls eruption, the 1.3 million year old eruption, is here. And just for comparison, this is the Bishop Tuff from Long Valley, shown here. And then this is the ash distribution from the 1980 eruption of Mount St. Helens. So these are very large eruptions. And in fact, the 630,000 year old eruption is estimated to have ejected about 1,000 cubic kilometers of material. And the 2.1 million year old eruption ejected about 2,500 cubic kilometers of material. And also, these have now been found to be even more distributed, so even more to the east of the U.S. So geological description of Yellowstone. Yellowstone is home to half of the world's active geysers, including Old Faithful and Steamboat geysers, as well as over 10,000 individual hydrothermal features. And on this map here, on this topographic map, everything in red and blue here is a mapped hydrothermal system in Yellowstone. You can see most of those occur within or adjacent to the 630,000 year old caldera, although there are a few down to the south, and namely these ones up here that extend beyond the caldera. And the picture to the right here, this is Old Faithful geyser. It's a cone geyser you can see here. And it was named very early on in the discovery of Yellowstone and the earlier expeditions. And back in the late 1800s, it was known to, it got its name from its predictable eruptions. And it was erupting about every 60 minutes back then. And that stayed until the late 50s. And there was a series of large earthquakes in the western U.S., mainly 1959, 1983. And that has extended the interval of Old Faithful to now about every 93 minutes. So I like to just show this picture of a geologist, a USGS geologist named Bob Christensen. He was instrumental in mapping the geology of Yellowstone starting in the 60s. And he just passed away recently, earlier this year. And he spent many summers hiking around Yellowstone and mapping its surficial geology. And in fact, on many field trips I was on with Bob, he would be talking about this little piece of rock outcrop, some way up there on the top of a mountain, and we would ask him, how do you know that? He's like, because I've been there. Because he hiked around literally everywhere in Yellowstone mapping it. This is his geologic map that he produced in his 2001 publication. You can see here, mainly here you can see in the greens, this is the Huckleberry Ridge tuff deposits from the 2.1 million year old eruption. This is the Lava Creek, in green, the Lava Creek from the 630,000 year old eruption. The purples are the Huckleberry Ridge from the 2.1 million year old eruption. This little blue down here is part of the Mesa Falls tuff from the 1.3 million year old eruption. And then all this pink inside the caldera, these are the subsequent rhyolite lava flows that happened after the 630,000 year old eruption that have since filled in the caldera in many places. And you can see here, these are the distributions for each of the three different explosive eruptions. You have Lava Creek here. It's broken up into Lava Creek A and Lava Creek B. You have Huckleberry Ridge Tuff here into three different parts, A, B, and C. And then you have the Mesa Falls Tuff distribution right here. So shown here, Yellowstone is an active volcanic system. It's very seismically active. It's one of the most seismically active areas in the western U.S. We average in Yellowstone about anywhere from 1,500 to 2,500 earthquakes per year. Most of them are very small. And those are shown in the red circles here. This is a map of earthquakes from 1972 to 2022. And then in Yellowstone, about half of our seismicity occur as part of earthquake swarms or clusters of events that occur. And some of these swarms can be, just tens of events. Some of these can be thousands of events. Sometimes they can only last a day. Sometimes they last multiple months. Yellowstone has been known to produce some large earthquakes. The 1959 Hebden Lake earthquake, magnitude 7.3, just west of the park here. It was big enough where it caused this large landslide in the Madison Canyon, where all this rock came down, come up the other side of the mountain, and then dammed up the Madison River and caused what's known as Earthquake Lake. This killed 28 people, most of them buried underneath the slide here at a campground. I mentioned Yellowstone as a hotspot. This is a image from Nelson and Grand, 2018, using tomographic tomography. And you can see here this large mantle plume of low velocity material coming up from about 3,000 kilometers all the way up to the surface to Yellowstone right here. Looking at more shallow, this is a paper that we wrote in 2015 looking at the crust. Again, these are tomographic images for different depth slices. And you can see here, this is the upper crustal magma reservoir here within the caldera. And one thing here in this paper that we found was we found an additional magma reservoir sitting at the base of the crust. And we interpret this as a basaltic partial melt sitting beneath here. So we were pretty much the first ones to find this dual magma reservoir system, and now it has since been found at many other volcanoes as well. Yellowstone is also very active geodetically. You can see here, this is through time. This is vertical deformation of the caldera. It goes up, it goes down, it goes up, it goes down on decadal timescales. This is vertical deformation in the Norris area. It tends to be the opposite polarity of the caldera. So when the caldera is going up, Norris is going down. You can see that in this INSAR image. This is an image showing uplift in the caldera, but subsidence here in the Norris area. And a lot of these big changes in uplift correspond with these big, large earthquake swarms that occur in Yellowstone. Scientific tradition, there are a lot of exploration from the US government beginning in the late 1800s. This is the Ferdinand V. Hayden expedition in 1871. This shows their expedition at Mirror Lake in Yellowstone. This is Ferdinand V. Hayden here. This is their map of the Upper Geyser Basin, and this is Old Faithful right here, where they named it. And one thing I like about reading their journals is this quote here. It says, in the morning, August 20th, about 1 o'clock, we had quite an earthquake. The first shock lasted about 20 seconds and was followed by 5 or 6 shorter ones. Duncan, who was on guard, says that the trees were shaken and that horses that were lying on the ground sprang to their feet. We had 3 shocks during the morning. So they experienced probably one of the first earthquake swarms while they were there. And of course, one thing that was very important is they brought with them Thomas Moran, a painter, and William Henry Jackson, a photographer, with them to document what they saw. And these paintings and these pictures were instrumental in Congress declaring Yellowstone the world's first national park the following year. Before these, it was just stories that many people did not believe about the Yellowstone system. And then one thing that's very interesting, you can see here, this is Mushroom Spring. Doesn't look too exciting, but in 1966, Dr. Thomas Brock of Indiana University collected one of the microbial mats here and isolated the bacterium Thermus aquaticus. And in the 1980s, Dr. Kerry Mullis identified an enzyme in Thermus aquaticus and named it Taq polymerase, Taq for Thermus aquaticus. And this enzyme is capable of replicating DNA at very high temperatures. And this led to the development of polymerase chain reaction, or PCR. And it became very useful in the medical field. And of course, if any of you have taken a PCR COVID-19 test, it's using this tool here that was developed because of Yellowstone science. So the main arguments: Yellowstone hosts over half of the world's geysers, including Old Faithful and Steamboat Geyser, which is the world's tallest geyser shown here. When it erupts, it's over 100 meters tall. And the Yellowstone volcanic region is accessible to the over 4 million visitors a year, and it's protected by Yellowstone National Park and the surrounding Forest Service land. And then these last photos here, these are two pictures showing just the scale of Yellowstone. These are pictures that were taken from two mountain peaks on each side of the caldera. So this is from the north looking south, and I've outlined the caldera here. The caldera is about 70 kilometers wide on its long axis and about 50 kilometers wide on its short axis. From here, you can see Mount Sheridan, which is where this picture was taken, looking towards Mount Washburn up here to the north. I leave you with this image of Old Faithful during a sunrise eruption, and I say thank you, and hopefully at some point you get a chance to visit Yellowstone in the future. Thank you.